Welcome to the inaugural session of the Joy Thomas Foundation's Career and Research Talk Series. We are pleased that you're joining us today. The Joy Thomas Foundation is to recognize and celebrate the life and contributions of Dr. Joy Thomas, a luminary and a pioneer in many ways. You can learn more about Joy, his contributions, and impacts at the JTF website. My name is Shashi Nambisan. I'm a professor of civil engineering and the director of the Transportation Research Center at the University of Nevada, Las Vegas. I'm delighted to facilitate today's session. It is with great pleasure that I introduce our guest today. He is Dr. Ajit Paranjpe, who will address the topic of microelectronics manufacturing and provide you some insights from his career. It is extra special to me to also note that Ajit and I were colleagues in our undergraduate program at our alma mater as batchmates at the Indian Institute of Technology, Madras. Now, a little bit about Ajit before we bring him on formally. Dr. Ajit Paranjpe is presently Senior Vice President and the Chief Technical Officer for Veeco. He has more than 30 years of technology development and senior management expertise and experience, primarily in the semiconductor capital equipment industry. His experience includes fabrication of semiconductor, optoelectronic, and magnetic thin film devices. Dr. Paranjpe has co-authored more than 50 peer-reviewed publications, and he has more than 65 US patents issued to him. Ajit earned his doctoral and master's degrees in engineering from Stanford University, and as I mentioned earlier, his undergraduate degree is from IIT Madras. So now, welcome Ajit.
Thanks, Shashi. Great to join you on this call and this conversation.
Great. So to get going, since this is all a part of the Joy Thomas Foundation initiatives, could you tell us how you know Joy and share some of your favorite memories?
That's a real pleasure, Shashi. So Joy has been a very close and treasured friend over several decades. It's a real tragedy that this friendship now only lives on in spirit. I was really fortunate to tag along with Joy on an academic journey through school, undergraduate at IIT Madras, and graduate studies at Stanford. He was my apartment mate through my 5 years at Stanford. At school, he backed the top academic awards. However, his fame was cemented when he ranked first in the joint entrance exam for the IITs, and of course, continued to excel at IIT. Truly, though, despite all the awe and respect so many of us had for Joy, I could not have wished for a better apartment mate at Stanford. So hopefully that gives you a flavor of how I got to know Joy.
Absolutely. I think you are one of several people who have had such close interactions with Joy, starting from the pre-college school, through college, and through postgraduate studies. So it's amazing. So we are delighted that you are our inaugural participant or speaker in this particular series. So in addition to what you just remarked on, what aspect of Joy's life stand out to you?
That's a great question because there are so many. It's hard to know where to begin. But apart from his academic brilliance, Joy was really what you'd call a walking and thinking encyclopedia. Remember, these were the pre-Google days, and a common refrain was "Ask Joy." In addition to his passion for knowledge, which is very well known, Joy loved cooking, and we were often treated to a feast of exotic dishes that he had conjured up. He made our apartment a magnet that attracted fellow classmates not only from Stanford, but classmates from IIT as well as school would often visit. During a recent call with my fellow classmates, many reminisced they consider our apartment their home away from home. Such was the welcoming atmosphere that Joy created. In fact, it's Joy's approachability, humility, and generosity, all of which translated into a genuine caring for others that really endeared him to so many. Joy loved to travel and explore. His knowledge of arcane facts, really from his quiz days, made the trips even more fascinating. During our time together, we traveled the west coast of the US and, along with another friend, crisscrossed the US, visiting friends and relatives along the way. Now, Joy was quite an avid photographer. He was never there without his camera, and that was a day before cell phone cameras were prevalent. And he kept a visual record. So even today, we remember exactly what we did, 20, 30 years ago. So that was fascinating. Hopefully, get a glimpse of the many aspects of Joy beyond his academic brilliance.
Thank you. Thank you for sharing some of these very personal and what might be not widely known from what people may read about his technical work or
Right.
contributions. So these are very keen insights that few people across the world have, and it's a delight that you are able to share some of that with us. So now transitioning to one of the purposes of this series is to talk about your career, the path that you have traversed, and some reflections. So I have a series of questions in this regard. So to start with, to help our audience identify who you are and where you are professionally, could you tell us about your current professional responsibilities and how you got here?
Sure. So I'm currently a senior VP and CTO for Veeco, and based in Somerset, New Jersey, USA. My roles include leading Veeco's organic growth initiatives in front-end semiconductors, compound semiconductors, and advanced packaging. Veeco, as you might know, designs and manufactures and supplies semiconductor process equipment. So prior to Veeco, I've served in senior management and technology development roles at many companies, including Torex, CVC, and Texas Instruments. Hopefully that gives you a flavor for my career path so far.
Okay, that's good. And so to get to this, while I remarked about where you earned your degrees, would you elaborate a little more about your educational background and training?
So I grew up in Bangalore, which has long been considered the technology hub of India. It's the home of well-known education institutions, several national and defense labs, and India's leading companies in aerospace, electronics, telecom, and infotech, to name a few. My dad worked at a national lab, and our school often organized field trips to the various institutions in Bangalore. Consequently, I was exposed to science and engineering, and most importantly, to stalwarts in the field, who served as role models all through my schooling. Many of my classmates had similar interests, and being part of a cohort helped immensely. In addition, during schooling, I dabbled in aero modeling, hobby electronics, amateur radio, and extracurricular science lab activities organized by the school. So, a career in science and engineering was almost an inevitable choice. After completing my BTech at IIT Madras, as you mentioned, along with you, I joined Stanford for graduate studies.
Okay, so that's your formal educational training. And so let me transition to some of your specific activities in the field. How did you get into the specific field? And when did you know this is what you wanted to do?
So that's a great question. My career has really been R&D oriented from the start, with a focus on microelectronics fabrication. So at Stanford, I became enamored by semiconductor device and process technology. And this is the primary field in which I have built my career. So semiconductor or chip fabrication technology is truly interdisciplinary. It melds the physical sciences such as physics, chemistry, and material science with several engineering disciplines, including electrical, chemical, and mechanical engineering. At Stanford, my research was funded by the Semiconductor Research Corporation, which provided regular interaction with technical staff from leading semiconductor companies. So I had a great deal of exposure to semiconductor chip technology and fabrication technology during my graduate studies. In addition, I did an internship at IBM, and after that, I became convinced that chip fabrication technology would be the launch point for my career.
Wonderful. So then once you got launched, so what were the professional options and opportunities you had over your career?
So after getting my PhD from Stanford, I chose to work at Texas Instruments in Dallas. And this was a really fortuitous choice for me since it really defined the trajectory of my career. Texas Instruments, as you know, is a recognized leader in the semiconductor industry with a rich legacy of innovation, including the invention of the first integrated circuit by Jack Kilby. So at TI, which had a very open and engaging culture, I was able to interact and work alongside highly recognized industry experts. And I really recall the discussions over lunch in the cafeteria with my experienced colleagues provided really numerous anchor points for further investigation and study. This was really invaluable since it broadened my technical interests and knowledge very early in my career. In retrospect, I can see how important this branching out and building expertise in adjacent domains early in my career was in providing a head start for opportunities in the future. So, a little bit about what I did at TI. So, at TI, I had the opportunity to work on the Microelectronics Manufacturing Science and Technology Program, or MMST for short. This was a government funded program, and its objective was to reduce the cycle time for chip manufacturing, which involves really hundreds of steps from weeks to days. It's quite a massive change in the way things were done, or really a paradigm shift in manufacturing technology from batch wafer processing to single wafer processing. So since single wafer process tools for many of these process steps were not available at the time or not commercially available at the time, we had to develop custom process tools along with all the associated processes and controls. So this was really a pretty fascinating endeavor for me coming from the university background with enormous potential for innovation and new concept development. So the end of this 5-year program, which was really a huge team effort, we demonstrated a world record cycle time of 3 days, which I think is still unbeaten, and to fabricate a chip. So today, the technology we developed, decades ago, which is single wafer processing technology, is the norm in all fabs worldwide. So it was pretty instrumental in changing the way things are done. So the interdisciplinary nature of process equipment and associated processes really convinced me that development of process equipment was a good career path for me and worth charting. So in the early 1990s, when I got started in my career, the process equipment industry was just getting started. The semi industry at that time was $50 billion a year, relatively small. Today, it's approaching $500 billion a year, a tenfold increase in size. And it's projected to grow to $1 trillion a year over the next decade, substantial growth in the future. So this shift to process equipment from chip fabrication itself came when TI licensed a lot of its core technologies from the MMST program to CVC, a startup company. And some of my TI colleagues decided to venture out and join this company, and they enticed me to join them eventually. And our mission was to apply some of the knowledge and learning we had from MMST program to thin film head manufacturing. At that time, thin film heads were undergoing a transition from magnetoresistor recording to giant magnetoresistor technology. And over the next several years, we developed and supplied tools for depositing and etching the critical magnetic layers that became now the mainstay of thin film head manufacturing worldwide. Another wave that I was really fortunate to ride was the transition to LEDs, or light emitting diodes, for displays and solid state lighting while at Veeco. So there we developed multiple generations of metal organic CVD, or chemical vapor deposition tools, to grow the light emitting layers. And most LEDs for displays and solid state lighting today, again, are manufactured on tools that we developed. So it was pretty fascinating to ride both of these waves.
Oh, wow. You've had a wide range of experiences, very impactful outcomes of that, and that touches the lives of people pretty much on a daily basis. But we just don't realize that we are using products of your work and your colleagues and your team's work. But along the way, I suspect that there were options you had to consider. So could you comment on the trade-offs and implications of these choices or options? You mentioned you went to the startup from TI and so on. So I suspect you had plenty of such options. So could you talk about the trade-offs and implications?
Yes, so let me maybe highlight just a few points that I think are sort of notable. The first thing that I realized is that being involved in the highest value add roles in a company typically has the best payoff both professionally and financially. So when you're making a decision, make sure you're looking at that aspect. It's because this often leads to good alignment between the goals of the individual, the company, and the industry. When all three goals are in alignment, that typically leads to positive and successful outcomes. Second, seeing a tangible link between the work and its external impact is both inspirational and gratifying. And I think I've been very fortunate to be involved in such roles in various companies. And third, these examples really illustrate that microelectronics manufacturing technology is really flexible and serves a breadth of applications. So this really creates opportunities for cross-fertilization and porting expertise across applications and device types. And this really allowed me to explore areas outside my immediate domain into an adjacent domain and branch out and to many different new areas. So hopefully that provides you some ideas of
Yeah,
some of the challenges and the way you look at career options.
absolutely. And along the way, a few moments back, you mentioned that this sector of the microelectronic manufacturing industry grew tenfold over the last about 30 years and is going to double in the next 10 years or so. So, where do you see the microelectronics manufacturing industry today? And more importantly, what do you see it evolving to in the coming years?
So at the start of my career, I remember that it was the time of the IBM PC. So when sort of the PC era, I mean, I got some of those huge clunky IBM laptops was my first laptop, not laptop, desktop, I guess. And now that transition to the mobility era, the era of smartphones. And now we're entering the era of digitalization and artificial intelligence. So today, most companies rank by market capitalization associated with the digital economy, unlike just a decade ago when a handful made the list. Now, sensors are generating more data than humans. Data will grow almost tenfold over the next decade, and all this data must be collected, processed, transported, and stored. So, as you know, chips of various types and flavors are really the engine that makes all of this happen. Consequently, the semiconductor industry is forecasted to double over the next decade, as I mentioned earlier. The strategic and national importance of semiconductors has actually just been recognized worldwide, and there are now many initiatives for substantial government funding going forward. The largest semiconductor companies, such as TSMC, Intel, and Samsung, have announced plans to committing spending hundreds of billions in new fabs worldwide over the next decade. And this level of investment is really unprecedented. On the technology front, the roadmap really highlights the accelerating pace of innovation required to achieve the power, performance, area, and cost goals for over the next decade. So many have highlighted the shortage of trained talent, which is, of course, one of the aspects of a career talk to support this forecasted growth. And it's good to note also that the average compensation in this industry ranks amongst the top quartile of all industries. On the technology front, you can see for decades, chips got faster, cheaper, and smaller by shrinking the two-dimensional device. When I started, we were in the sort of a 1 micron era, which means the smallest dimensions of the device were approximately 1 micron. Today, the finest dimensions in chips approaching 10 nanometers, a hundredfold reduction. In the span of a few years, we've gone from two-dimensional devices to three-dimensional devices, and now we're planning to stack these devices vertically to make a 3D structure. Even the chip package has gone from a single die to multiple die, often stacking of die, which is called advanced packaging. So advancements in microfabrication technology have not only advanced the chip roadmap, but have actually led to ancillary growth in photonics, power conversion devices, RF devices, to name a few. So this synergy and virtuous cycle of growth, I expect, will continue through the ecosystem. So I think for students or professionals who are thinking of entering this kind of such an industry, such a interest in a fast-paced, interdisciplinary STEM career with significant potential for innovation and growth, I think they should certainly consider a career in microelectronics manufacturing.
Excellent. Wow, that was a pretty broad, but at the same time, somewhat in depth in some specifics of your particular industry and your experiences and your insights. Thank you about that. And you talked about the ubiquitous nature of these chips. My work is in transportation, and for people who follow the popular press, you see over the last few months, there's been a
Mhm.
shortage of chips that has led to a significant adverse impact on manufacturing of automobiles. Okay.
That's correct.
Yeah, that's just a side note to tie the two of our work together, but it is way beyond that, beyond transportation. I strongly feel that what you talked about, the role of chips in harnessing the power of data that we get from sensors of various types, is absolutely critical in all walks of life, in all industries for the most part across the world. So now, for someone who wants to get into microelectronics manufacturing, what should they focus on learning, and how might they go about addressing these learning needs?
So fortunately now there is really a wealth of information online to become familiar with this industry. So a good place to begin is to look at the websites for the leaders in the ecosystem, including chip manufacturers, process equipment suppliers, and materials vendors. So these websites will really provide an overview of the products and core technology and where it's headed. Of course, the job listings provide a flavor for the types of positions and requirements. And given the importance of the industry, actually, there are several market research companies and analysts who publish reports regularly on the trends in the industry and the challenges being faced by the industry. For those who are more curious and more technically oriented, you can certainly attend the conferences or even look at the proceedings of conferences such as the IEEE IEDM and the VLSI Symposium, which are sort of the top-notch conferences in this arena, for a glimpse into the future. From an academic perspective, the disciplines of electrical engineering, chemical, material science, and applied physics are probably a good starting point, provide the essentials in terms of academic training. Of course, you need to note that most positions now require advanced degrees. In fact, some companies only hire PhDs in pretty much any role. And that has to be done in concert with some working knowledge. So many universities, of course, offer relevant courses, and some of these now are available online. One thing I found is pursuing graduate studies in a university that is an active participant in a multi-university consortium will really provide maximum exposure to the challenges and trends in the industry, in addition to networking opportunities with industry participants. And this often leads to internships, which will then provide a first-hand view of working in an industry environment and hopefully position yourself for a future job in the company. So I think there are a lot of resources that are available to students today, and they should try to leverage as many of them as possible in making the wisest decision with the information they have.
Thank you. Thank you for those insights too. So as we try to wrap up this session, would you summarize key factors that have shaped your career?
So I think the saying, the only constant is change, really aptly describes the semiconductor industry, given the relentless pace of change. I think I've already talked about a lot of the scaling that's happened. And technology transitions and microelectronics drives waves of growth. And I've really benefited from such waves during my career. So looking back, I can reflect upon my career choices and decisions and how they shaped my career. First, I think a passion for the subject that remains evergreen is really important because that kept me engaged and motivated. Second, the fast pace of innovation and diversity of applications in the industry really created opportunities to develop my aptitude and my experience. Third, the rapid industry growth created a virtuous cycle that combined continuous learning, the drive to succeed, and tangible professional growth. So the confluence of passion, ability, and diligence, and more important and equally important, reinforcing external factors, are really common ingredients of any successful career. I think this really holds true for me as well.
Wonderful, wonderful, very aptly and succinctly summarized. So thank you, Ajit, once again, for providing a peek into your interactions with Joy. We also appreciate learning about your professional experiences and your thoughts on career opportunities in your field and some suggestions to people who are interested in pursuing career opportunities in this area. So thank you very much once again.
Thank you, Shashi.
It's my pleasure. So I think we have time for a few questions, and I believe we have a few questions that have been posted. So I'd like to call on for the folks who are moderating the questions to pose one at a time. Vin, I believe you have one.
Hi, Ajit. Thanks so much for having me here. I listened to your conversation today. I think it was an awesome conversation, and it touches on the fact that people like you have been at the forefront of pioneering changes within the space, and the decisions you've made in the past is impacting the lives of millions of people, if not billions of people today. So that's amazing to hear from you. By the way, as an introduction, my name is Vinod, and I work in HR in the Bay Area, and I'm part of the Joy Thomas Foundation work. So think some possible questions which are probably coming at you is around these topics of you have recruited people, especially interns from some of the newer IITs in the recent past. So could you briefly reflect on your experiences with the interns? And secondly, is there any advice you have for undergraduates and graduates who are in IITs right now or in other engineering colleges within India in terms of what they can be doing better?
Absolutely. So we know the pleasure to answer those questions. So I think most of my professional career has really been in the smaller companies, and our approach to hiring has been very targeted and selective. Obviously, as a small company, we have to be very careful about whom we bring on board. So just a little bit about the kinds of people we look for, because I think that might provide pointers to students. So really, for internships or entry level positions, we look for candidates who have passion and intellectual curiosity for the subject. We think that's absolutely important to be successful. They have to be resourceful. In a small company, there's a limited amount of handholding that's possible, and they have to be fast learners as well. You're going to be thrown a problem, and you need to figure out how to bootstrap and pick up information, become part of a team, and try to get information and learn as quickly as possible. And of course, you've got to have the academic aptitude to be successful. But just academic aptitude is not sufficient. It's a necessary but not sufficient condition, I would say. And what I found is that when you really match such candidates with the right assignments, you really get a mutually rewarding experience. And quite often, an internship, at least in my experience, has turned into full time employment for many of our interns upon their graduation. Unfortunately, I don't have a lot of experience hiring directly from IITs or India, so I really can't comment on that. I may have done just limited there, but hopefully, these other tips will help the students. I think your second question is related to what else can students do to prepare for a career. Is that correct?
It is Ajit, yes.
Okay. So to me, really, the way I look at it is education and learning are a lifelong experience. Your formal education only provides a ticket, entry ticket to future professional career. And so, in trying to establish a foothold, I think internships are relevant, even part-time opportunities that complement your relevant part-time opportunities that complement your education in preparing for professional career are pretty important. In starting out, of course, identify career areas where interest and aptitude are aligned with external factors. I think I talked about the importance of external factors because these external factors will provide a tailwind for your professional growth. Absent the external factors, it might be a struggle, right, to grow. And really being in the right place at the right time helps. And I think many of us have discovered that along our careers as well. And so, with that, I'd like to wish good luck to everyone, and hopefully, this helps.
Thank you. Thank you. Vinod, do you have any other questions that were?
Ajit, I have probably one more question to you, and this is
Mhm.
around the topic of needing a PhD to be in this sector. You touched on it very briefly, saying that sometimes you absolutely need a PhD degree. So I just want to check in with you in terms of if people who have master's degrees and work experience would will that compensate for having a PhD degree, and what are your thoughts on this topic?
Yeah, so Vinod, I think that is, I think it depends a lot on the company. I mean, many companies are happy to take master students with relevant work experience because it's a combination of your academic background and your work experience. That's really going to define how successful you're going to be. I think for entry level positions, certainly there's huge demand for talent, but at the same time, companies are extremely selective. So, in entry level positions, if you only have a master's degree without much work experience, or you have a PhD, the PhD tends to win out simply because you have more relevant work experience and you can begin contributing on day one. However, if you have a combination of masters and work experience, that's fine too. And many would start in this and then maybe diversify into other fields such as product marketing or technical marketing. So I don't think a PhD is essential. Certainly, if you want to be in R&D and you want to advance to the highest levels of responsibility in R&D organization, a PhD is pretty much mandatory. I don't think it's like being in a university. Without a PhD, you're not even authorized to teach. Hope that helped answer your question.
Thanks, Ajit. Very helpful. Appreciate it.
All right. So I think it's time to bring the session to a close at this time. And I want to thank Dr. Ajit Paranjpe for making time and sharing his insights about his interactions with Joy and also his thoughts about the semiconductor manufacturing industry and suggestions or advice for individuals desiring to pursue career opportunities in this field. I also want to thank others at the Joy Thomas Foundation who are working behind the scenes to make this session possible, the logistics of it, the recording, so on and so forth, editing. So thank you. Finally, I hope that you have enjoyed this session and have learned something or have things to take away from the session. And we appreciate your interest in the activities of the Joy Thomas Foundation. We look forward to seeing you in future sessions and your active participation and contributions to the Joy Thomas Foundation's initiatives. With that, I sign off at this time. I'm Shashi Nambisan. Thank you so much.
Thanks, Shashi. It was a real pleasure to join you in this conversation, and good luck with the Joy Thomas Foundation. Thank you.
Over and out, folks.